in our last class of nodal analysis, the voltage source was between a reference node and a non-reference node. See the figure. This current source is coming between the reference node and a non-reference node, while this voltage source is coming between a reference node and a non-reference node. Now we will see the case when the voltage source is coming in between two non-reference nodes. Earlier, see, between these two non-reference nodes there was no voltage source, while here one voltage source is coming in between two non-reference nodes. This is called a super node. In this class we will be studying how to analyze this circuit containing super node analysis. See, just to recollect that in super mesh analysis we temporarily removed, that is opened, the branch containing that current source sharing two meshes. See, this current source was coming in between mesh 1 and mesh 2 like this. What we have done? We have opened that path. Now between mesh 1 and mesh 2 there came a super mesh. While in super node analysis we will be temporarily shorting that voltage source coming in between two non-reference nodes. See here, this voltage source came in between two non-reference nodes. So here a super node is there. What we will do? We will be shorting it. So temporarily we have removed that one and shorted, and this part can be somewhat written as like this. These are becoming one node. So in the case of mesh analysis we opened that current source, while in node analysis we shorted that voltage source. In super mesh current source is open for super mesh analysis, and in super node voltage source is shorted for super node analysis. In this example we are asked to find the current through this 10 ohm resistance in the circuit shown. First of all we will mark the nodes. See, here three branches are meeting, so one node is coming here, another one is coming here, while here 1, 2, 3, 4 branches are meeting, and we can mark one node here. Let us take this node as the reference node V0, while this is a non-reference node V1, this is another non-reference node V2. So V1 and V2, V1 and V2 are non-reference nodes. As between these two non-reference nodes one voltage source is there, this forms a super node. So we have studied that to solve this example we will temporarily remove this voltage source and short it. This we will draw as, we will temporarily remove this one and we will short it. Once again we will mark the nodes here. Here it is V1, here it was V2, and here came the V0, which is the reference node, while V1 and V2 are non-reference nodes. Now we will mark the currents. Here already the current is given and its direction is in this way. So here 2 ampere current is flowing in this way. Let I1 is the current flowing through 10 ohm in this direction. I2 is flowing through 20 ohm in this direction, and here it is positive voltage, so current I3 will be coming in this direction. At node 1 and 2, which we joined together, removing that voltage source and shorting, by Kirchhoff's current law, current arriving at a junction is equal to current leaving from the junction. That is, here I3 is coming towards the junction, while 2 ampere I1 and I2 are going away from the junction. Therefore 2 plus I1 plus I2 is equal to I3. By Ohm's law, I1 is equal to V1 minus 0 divided by resistance 10 ohm, that is V1 by 10. I2 is equal to V2 minus 0 divided by resistance 20, and I3 is equal to, see here voltage is V2 while here the voltage is 5 volt. So difference in voltage is this 5 volt minus V2 divided by resistance 1. Let the equation of this current be 1. So substituting the values of current in this equation, we will get 2 plus I1, that is V1 by 10 plus I2, that is V2 by 20. V2 by 20 is equal to I3 is 5 minus V2 by 1. 5 minus V2 by 1. Here LCM is 20. Bringing this term to left hand side and writing, here comes 40 plus 2V1 plus V2 plus 20V2 minus 100 is equal to 0. While bringing this 20 to right hand side, it becomes 0. Therefore, our equation becomes plus 40 minus 100, that is minus 60 plus 2V1, then here it is V2 and 20V2, that is plus 21V2 is equal to 0, or 2V1 plus 21V2 is equal to, we can bring this minus 60 to right hand side and write as plus 60. Let this is equation number 2. Now see, between nodes V1 and V2, positive is coming here, so that V1 is greater than V2 by 10 volt. Therefore, V1 is equal to V2 plus 10, or V1 minus V2 is equal to 10. Let this is equation number 3. Solving equations 2 and 3, we will get V1 is equal to 11.74 volt and V2 is equal to 1.74 volt. We are asked to find the current through this 10 ohm resistance. Here V1, the voltage is 11.74, while V0 it is 0. So current through 10 ohm resistance is, current through 10 ohm resistance is I is equal to V by R, that is V1 minus 0 divided by 10, that is 11.74 divided by 10, which is equal to 1.17 ampere. In example 2, we are asked to determine the current in the 5 ohm resistance of the circuit shown in figure 6. So first of all, we will mark the nodes. Here this branch containing current, this resistive branch, this resistive branch, this branch and this branch are meeting, and here one node is coming. Here 3 branches are meeting and another node is coming. Like this, here one more node and also here one more node. In this one, we have to take one as a reference node. Let this is the reference node and these are all non-reference nodes. This reference node, we will ground it and the voltage here will be 0. See here, for analyzing the circuit, one voltage source is coming in between 2 non-reference nodes. Here one super node is coming and we have to apply super node analysis to redraw the circuit. For super node analysis, what we have to do? We have to temporarily remove the voltage source coming between 2 non-reference nodes. We have to remove this voltage source which is coming in between these 2 non-reference nodes and we will short circuit it. Let us mark the voltages at each node. This is the reference node and voltage here we will mark as V0. Let the voltage at node 1 is V1, at node 2 V2 and at node 3 V3. Next we will mark the currents entering or leaving each node. Here is a current source, the direction of which is in this way. So here 10 ampere is flowing in this way. As this is a resistive branch, current will be flowing away from this branch. Let it be I1. In this branch, as it is a resistive branch, let current I2 is flowing from V1 to V2. At this node 2 is a resistive branch, let this current I2 is flowing from V2 to V1. And in this branch, let current I3 is flowing from V2 to V0. Here in this branch, here is a voltage source. So let current is flowing upwards from here to here and let it be I4. In this branch, which is a resistive one, let current is flowing away from V3 and let that current is I5. At node 1, by Kirchhoff's current law, current entering is equal to current leaving. That is 10 ampere is equal to I1 plus I2. Let this is equation number 1. By Ohm's law, I is equal to V by R. That is this I1 is equal to V1 minus V0 divided by the resistance 3 ohm. I1 is equal to V1 minus V0 divided by 3. As V0 is equal to 0, this can be written as V1 by 3. I2 is equal to V1 minus V2 divided by this 2 ohm. Therefore, this equation number 1 can be written as 10 is equal to I1, that is V1 by 3 plus I2, which is V1 minus V2 by 2. LCM is equal to 6. Therefore, 10 is equal to 2V1 plus 3 into V1 minus V2. That is equal to 2V1 plus 3V1 minus 3V2 divided by the 6. This can be rewritten as 2V1 plus 3V1 is equal to 5V1 minus 3V2 is equal to, when this 6 is brought here, it becomes 60. Let this is equation number 2. Then here, see, at this supernode created by V2 and V3, at supernode of V2, V3 by Kirchhoff's current law, I2, I3 and I5 are going away, while I4 is coming towards the node. As per Kirchhoff's current law, current entering is equal to current leaving that junction. That is I2 plus I3 plus I5, which are leaving the junction, is equal to current entering, that is I4. Let this is equation number 3. By Ohm's law, I is equal to V by R. That is I2 is equal to V2 minus V1 by 2 ohm. I2 is equal to V2 minus V1 by resistance 2 ohm. This I3 is equal to V2 minus V0 by 1 ohm. V2 minus V0 by 1 ohm. As V0 is 0, this becomes V2 by 1. Next, I4 is equal to, here this 10 volt is coming here and V3 is coming here. So, 10 volt minus V3 divided by 5 ohm resistance. 10 minus V3 divided by 5 ohm. And I5 is equal to V3 minus V0, which is 0, divided by 2 ohm. That is V3 divided by 2 ohm. Substituting this in equation number 3, equation number 3 becomes, first is I2. I2 is V2 minus V1 by 2. V2 minus V1 by 2 plus I3 is V2 by 1. V2 by 1 plus I5 is V3 by 2 is equal to this I4, 10 minus V3 by 5. V3 by 5. Bringing this term to left hand side, the equation can be written as V2 minus V1 by 2 plus V2 by 1 plus V2 by 2 minus 10 minus V3 divided by 5. This is equal to 0. So here LCM is equal to 10. So the equation becomes 5 V2 minus V1 plus 10 V2 plus 5 V2 minus 2 into 10 minus V3 is equal to 0. When this 10 is brought to right hand side, it becomes 0. And further simplifying this equation, we will get minus 5V1 plus 15V2 plus 7V3 is equal to 20, and let it be equation number 4. Here the supernode developed by V2 and V3, V2 is at positive side, so V2 is 20 volts more than V3. So which can be written as V2 is equal to V3 plus 20 or V2 minus V3 is equal to 20, which is equation 5. From equations 2, 4 and 5, we will get V1 is equal to 18.94 volt, V2 is equal to 11.57 volt and V3 is equal to minus 8.42 volt. We are asked to find the current through this 5 ohm resistance. Current through 5 ohm resistance is equal to 10 minus V3 divided by 5. V3 we have found as minus 8.42 volt. So This becomes 10 minus 8.42 divided by 5, which is equal to 3.68 ampere. If you found any difficulty in understanding any terms used in this class, you can go through my previous classes, the links of which are given below. Thanks for watching. Please like it, share it and subscribe it by pressing that bell button so that you will be receiving all the notifications of my future videos also. See you next time. Bye.